Hi everyone, in this video we will solve this puzzle, circular jail cell. So in this question you're given that there is a circular jail which has 100 inmates, which means there are 100 prisoners inside the jail, and each cell contains only one prisoner, and there are 100 such cells. So there are basically 100 cells having 100 doors, and these are numbered from D1 to D100, right? So each cell has one prisoner inside it, right? So what it is given, one night the jailer gets drunk and starts running around the jail in circles, which means he goes across entire jail, and in each round he opens each door. In the first round he opens each door. So after the first round all the doors are open, and in the second round he visits the doors which are multiples of 2. So it goes to this door and he shuts the door, so he closes the doors which are even numbers. Okay, and in the third round he visits the doors which are multiples of 3, and it flips their state, which means if the door was open it is going to close that door. If the door was closed, he will make it open, right? And this goes for 100 such rounds. So he does the same work for 100 rounds, and each round he goes to every door and he flips the state of the door, right? If the door was open, he's going to close it. If the door was closed, he's going to open it. So your task is to find out how many doors are open after the 100 rounds. So this is what you need to compute, right? Okay, so now let's think about the solution to this problem. So clearly we can say a door having a number D will be open if the prisoner is going to come to this door odd number of times, right? Odd number of times. So when you will come to a door odd number of times, for example, let's say you go to the door, you open it, you close it, open it, close it, and open it, right? Because if you go to a door even number of times, it will be finally closed. So let's talk about the door number 12, right? So in what rounds you will come to door number 12? You will come in the first round, second round, third round, fourth round, sixth round, uh, and the 12th round, right? So these are the only rounds in which you will come to door number 12. So clearly we can see these numbers are nothing but the factors of 12, right? So, or the divisors of 12, right? So these numbers are the divisors of 12, and since 12 has 6 divisors, which means the jailer will come to this door 6 number of times, it will be finally closed. So we want to find out those numbers which have odd number of divisors, right? So how do we find out those numbers which have odd number of divisors? So yeah, so there is a property, right? Okay, so if we talk about number of divisors of any number 12, we also know that these divisors occur in pairs. So if you have 1, you also have 12. If you have 2, you also have 6. If you have 3, you also have 4. Clearly we can see all the divisors occur in pairs, right? And if you take product of those numbers, it becomes 12 or 36 or whatever that number is, right? But for some numbers which are perfect squares, you have odd number of divisors. For example, if I talk about the number 36, you will have 1, 2, 3, 4, 6, 9, 12, 18, and 36. You have 4 and 4 8 and 1 9. You have 9 such divisors, right? So for the door 36, the jailer will come to this door odd number of times, and hence this door will be finally open. So why it is having odd number of divisor? Because of this 6. Because 6 cannot be paired with any other divisor except itself, because 6 into 6 is 36, and this 6 will be counted only once. So all numbers 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, up to 10 square, which is 100. Only these doors will be open, right? and clearly you can say they are nothing but 10 doors, right? So the solution to this puzzle is 10 doors, and that's how we could solve this problem.